All right, part B is evaluating an exponential function with base e. E is sort of like pi in the thing that it's an irrational number and it's always the same number. On this calculator here, if you look above the natural log, you see in yellow e to the x power. If I'm going to do e to the first power, what I have to do is I do shift and hit the natural log, and then I just put the exponent right behind it. You could use parentheses around it. If you have a Texas Instrument calculator, it automatically puts the parentheses there. But e to the first power should give you 2.7182, blah, 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 blah. So e is roughly 2.7, but it's one of those irrational numbers that keep going and going and going. So when I'm going to do this one, it says the number of bacteria P of t in a certain population increases according to the following exponential function, where time t is measured in hours, and we want to find our answer after 3 hours. So we would do 190, and then we do the e by hitting shift natural log, and then since I have more than one thing after that, I'm just going to put in parentheses my 0.08 times my time, which is 3 hours. So you don't use a caret key. I don't know why. You think you should. But on this calculator, you don't use the caret key. You just put whatever the exponent is in parentheses behind your number, unless it's just one number. Then you don't need the parentheses. 190. Shift natural log, parentheses, 0.08 times 3. And we are rounding to the nearest gram, so what are you coming up with? 242. 242, that's what I'm coming up with. 242. And like I said, if you're using a Texas Instrument calculator, it automatically puts the parentheses for you, but on Casio, you got to put the parentheses in there. And so after 8 hours, all we're going to do is just change our 3 to an 8. So 190 e 0.08 times 8. And rounding to the nearest gram, we get
360.
360, yep. Betty, you getting those to work? So, number 8. Suppose that the velocity v of t in meters per second of a skydiver falling near the Earth's surface is given by the following exponential function, where time t is measured in seconds. And so we've got 54, and then we'll have 1 minus e, and then we're going to have parentheses, negative 0.24. Our time, since it's the initial velocity, would be 0. So times 0, and close our parenthesis for our e power and for our other set of parentheses that we have. And we are getting what for our initial velocity? We get 0. Yeah, they haven't taken off yet. He's probably still in the plane. So he has no velocity. So then we have 54, 1 minus e to the negative 0.24 times 5 seconds. That one I better figure out. Parenthesis. And we're rounding to the nearest whole number. I got 38 also. So 38 meters per second is how fast he falls. Number 9. A species of animals is discovered on an island. Suppose the population size P of t of the species can be modeled by the following exponential function. So we have 400 over 1 plus 7e to the negative 0.1 t. Now we could do it in 2 steps and find our bottom number first and then take 400 divided by the answer, or we need to put parentheses around the entire bottom. So I would say 400 divided by, and since the calculator has to do the bottom part first, we got to put parentheses around there. 1 plus 7e, and then for our e, we also have to have parentheses around that. Negative 0.1 times our time, since the initial size, time is 0. So 50 is our initial population size. This would give me e to the 0, which is 1. 1 times 7 is 7. 7 plus 1 is 8. And 400 divided by 8, hey, is 50. The next one probably won't turn out so nice. After 8 years, so 1 plus 7e to the negative 0.1 times 8. Parenthesis, parenthesis. Negative 0.1 times 8. 96. So our initial population started out at 50. After 8 years, we now have 96 of whatever our species is.